Alright, today in this video I'm going to be explaining IPSec or Internet Protocol Security. Hopefully this is going to be your one-stop shop on how it works, what ports and what type of IP protocol it uses, or the protocol number, talk about the different modes, and I'm even going to do a couple packet captures so you get to see this in action. Alright, my name is CCNP Seth, so let's get into it. So the first thing I want to talk about for IP security is, what does this protect? Now, it does four things for us. It protects our data as we send information from one network to another network, but we have to go through our ISP or the public internet. So as we send traffic, so let's say I'm a bank, and then this is the headquarter bank, corporate, and then these are our little branch routers, right? And they're out all over the world. We're sending transactions back and forth, but we have to go through our ISP right here. Well, we're not going to send all of our customers' information in clear text back to the headquarters. No, we will not do that. That information will get stolen. Huge thing. So we need to protect it. So we actually use IP security for that, or that is an option for that. And what IP security protects us from, or what IP security provides, is confidentiality, integrity, authentication, and anti-replay. So confidentiality, that's that encrypting of the data. Integrity is making sure as I send these transactions, it's not altered en route. And then authentication, well, the person sending it, I know exactly who that is. So I'm authenticating the sender and the receiver. And then anti-replay is where we use sequence numbers, and if someone were to duplicate this packet, and I'm using IP security, with that duplicate packet that's going to be sent to me, I'm going to discard it. So that's what IP security does for us, those four things. Now, IP security, it uses the IP protocol number 50 or 51, depending on if we are doing authentication header, AH, or ESP, encapsulating security payload. So they do two different things. AH, all that does is just, it authenticates the user. When we think of IP security, we always think encryption, but AH does not do that. All we're doing, again, like I said, authenticating the sender and the receiver. ESP, however, does the encryption, and you could actually run ESP with AH, so you can authenticate the distant end and also encrypt it. Now, as we are building these tunnels, because remember, IPsec, these are tunnels. We're building a secure tunnel from one end to the other. So that's what we're going to do. And as we're negotiating these tunnels, we are going to be using either UDP port 500 or 4500. It depends if one of the routers in the middle of our tunnel, if it's doing NAT. So if we're doing NAT, IPsec will detect that and it'll switch over to port 4500. If not, like in my topology that I have here, no NAT. So we're going to capture these packets and we'll see it using UDP port 500. Now, once we establish phase 1 and phase 2 of IPsec, because it actually runs in two phases, and I'll show that as we do these captures, is we are either going to be running in tunnel mode or transport mode. Okay. Now, how these are used, tunnel mode is used between routers. Okay. Routers, or gateways they like to say, they are the one who's doing the encryption. So that would be tunnel mode. And then behind it would be a whole bunch of computers, right? Computer, and then distant end computer, right? So these computers, they'll send the traffic to the router in clear text. Then if it needs to be encrypted so it can go to the other end of the tunnel, then router 1 will encrypt it, send it through the tunnel. Router 4 will get it and then decrypt it, so then it'll be a normal unencrypted packet as it gets to the end host. Now, transport mode is when two computers are talking directly to each other and they want to build that tunnel themselves. So again, instead of the router doing the work, it'll be the computer, and like let's say he's talking to a server. If this computer wants to send an encrypted IPsec message to the server, then they would normally run it in transport mode. All right, and that's kind of like the example I have down here. Encrypted telnet or RDP session from a workstation to a server. Yeah, so that would be transport mode. The big thing, though, between tunnel and transport, other than those two, gateways, or it's a client and a server, is tunnel mode. It adds an extra header which costs 20 extra bytes. Like, okay, well, if we're trying to send large amounts of data, then that extra 20 bytes, that's going to add up. So now we're going to have to send more messages. So tunnel mode, it's an extra 20 bytes because we add an extra IP header. Okay. So that's another difference between tunnel mode and transport mode. Now, I already have a topology set up so we can see these messages go back and forth. So I'm going to show you AH in transport mode and then ESP in tunnel mode right here, okay? So let me start R1 and we'll bring up him. And then I'm actually going to capture this section right here from router 3's point of view, and we'll see these messages go through. Now let's bring up this. Now I said that there's two phases, and we will see this with IPsec. So actually exit ping 4.4.4.4 from the source address of 1.1.1.1. What I'm doing here is I'm going to be sending ping packets from loopback 1.1.1.1 to the loopback address of 4.4.4.4, which is on router 4. Okay, so that's what I'm doing right now. And let's go back. And let's bring this up. Bam. And here we go. So this identity protection main mode, that is IPsec or IKE phase 1. And you can see here, look at that source and destination port. It's actually using UDP port 500. See, user datagram protocol. And then quick mode still uses UDP port 500, but now this is phase 2 of IPsec. And if you don't know anything about IKE phase 1 or phase 2, at certain, like if you're studying for CompTIA, I don't believe you need to know the details of that, but just know that it uses UDP port 500, stuff like that. Okay. Then after the phase 1 tunnel's built, now the phase 2 tunnel's built, now IPsec data could actually flow through, and here are those ping packets that I sent. The send and receives of those echo requests and replies. And here you get to see the IP protocol ESP payload is 50. All right. And then you get to see the encapsulating security payload, which is this. This is the encrypted data. And this data is actually ICMP packets. All right. So you can't see it. So cool. That is what ESP does. Now, let's close that out. Stop that capture. And we'll start this. One other thing I want to show you, like, how do you know if you're running tunnel mode or transport mode with ESP? Since there's an extra header and tunnel mode preserves that original IP header, like it says right here, the original packet or the original IP packet is protected and it just adds on an extra header. In ESP, you cannot see that. But if I was running authentication header and everything is in pretty much clear text, you will see that extra header. But I don't have that actually set up at the moment because I wanted to show you the encryption portion. But now, Oh, wait, hold on. Before I get there, I'm jumping ahead of myself. How do I know if I'm running tunnel mode in my ESP section? So here's the command in the router's command line. Show crypto IPsec security association interface E0/1. I'll just hit enter. This is all mumbo jumbo stuff if you're actually configuring it on the router, but you'll notice outbound ESP tunnel, that's tunnel mode. And also there's the word tunnel up there as well. So that's how I know I'm running tunnel mode. All right, so now let's look at AH and transport mode. I'm already running Wireshark, and I'm running OSPF between these two routers, open shortest path first, and I'm encrypting it. Well, I'm using IPsec to authenticate each other. And let's look at the actual packets between them. So these are OSPF hello packets, and if I open that up, notice I could actually see the data. Like, all this is in clear text, all of it. But how do I know I'm actually running IPsec then? Thought it was supposed to encrypt it. Well, ESP encrypts it. Authentication header does not. And how do I know I'm running authentication? Well, if you look in the layer 3 header, bam, there's that IP protocol number, authentication header 51. That's AH, IP protocol 51. Then you actually have your authentication header itself, right? And then the payload, OSPF stuff in clear text, right? Now, what mode am I running? Well, I have it written here as transport mode, but how do I actually know? Again, go into... Nope, oh, sorry, that's not it. Go back into the router and do that show crypto IPsec security association interface Ethernet 0/0, hit enter, and then we will see that it's running in transport mode. See, transport and transport. All right, and if you want a quick visualization of how the packet is broken down, if we scroll down on this website, I'm using networklessons.com. Here it is, authentication transport mode and authentication header tunnel mode. This is the same format even with ESP. Okay, and then that's just how it looks. See, tunnel mode, there's that original IP header. It's preserved. It doesn't do anything. It's unchanged. It just adds an extra header, and that's where that extra 20 bytes comes into play. And then in transport mode, you take that IP header that was right there, and we moved it to right there. And the only thing we added was that IP protocol number 50. Protocol 50. Or 51, but this is AH, so of course that's protocol. Well, actually, that's 51, I'm sorry. AH is 51. Right? Yeah, AH is 51. So, that's it. That was like a quick but detailed overview of what IPsec is. If you guys have any questions, I mean, this is on YouTube, so go ahead and write it in the comments below. Subscribe if you like. But yeah, that's it. I hope this was informative for you, and I'd like to thank you for viewing.